Okay, so we're going to go through this sample problem from the notes. Ammonia is an important fertilizer and is also used in household cleaners. In the industrial production of gaseous ammonia, gaseous nitrogen and gaseous hydrogen react to form the product. What is the balanced equation or the balanced chemical equation? Now, here we have a word question. First, we need to identify the parts that are going to be important for us for doing our question. So when we're given a question like this, we might look at it and say, okay, we have ammonia. Ammonia is the product, okay? So ammonia will be on one side of the equation. We have gaseous nitrogen and gaseous hydrogen that react to form the product, which is ammonia. And so we know that in the word equation, we have, okay, the word equation, nitrogen, gaseous nitrogen, and gaseous hydrogen, okay, and if we were indicating state, we would put a little g in parentheses on either side there, yield or produce ammonia. And so this is what the word equation version is when we're starting it out. Now, in a sample problem, or pardon me, in a problem, you might not be given this. You might just simply be given the skeleton equation. Okay, and so the next we write the skeleton equation by writing the chemical formula for each substance. Okay, remember that nitrogen and hydrogen are diatomic molecules in this particular case. Diatomic means that in nature they generally are they come as twos. Okay, and so we have two nitrogen and two hydrogen. Okay, they yield then, and if you were to go to your periodic table of ions in the polyatomic ion section, you would see that ammonia is NH3. Okay, and so that's how we write this out. We start by using the words. Okay, we go to our periodic table, and we see that nitrogen's symbol is N. We know that from our notes that it's a diatomic molecule, so it comes as N2. And then H, or hydrogen, comes as 2 as well. And then, of course, this getting from our periodic table of ions. So what do we do when we want to solve this equation? Well, finally, we use coefficients to balance the equation. First, consider the compound in the equation. Since elements are easier to balance later, okay, meaning single elements, okay, so here's a compound, right? We have two elements together. These guys are a lot easier to do later, and so we save them for last. Okay, you need to have two nitrogen atoms in the product, right? We have two nitrogens in the product here, and so we need to have two in the reactant side, okay, as well. Now you'll remember before that there is nothing in the coefficient section here. Now in this section, we've added a coefficient. This is the only thing we can change is coefficients, or the numbers in the front. Okay, and so we've added a 2 because there's two nitrogen on this side, meaning that there's two nitrogen on, we want to make two nitrogen on this side. Okay, and so we've balanced that out. Now it's still not completely balanced because we have two hydrogen on this side and we have three on this side. But pardon me, we have two times one is two nitrogen, two times three is six hydrogen. And so we need to make this into a six. So I'm going to ask you, what do you think will need to go here? What number makes a two into a six? What do you have to multiply it by? Pause if you need to figure it out. Okay, that's correct if you put down a 3. Okay, 3 is the correct thing. Okay, now the nitrogen atoms are balanced, but the hydrogen atoms are not balanced because there are two hydrogen atoms on the reactant side and 6 on the atoms of the product. Okay, therefore add a coefficient of 3. okay, right here to make it a 6.